Welcome to Ethiopia Tutor Center. Today we will discuss Ethiopian University Entrance Exam 2011 Chemistry sheets. Look, let us start the first question. Who used the cathode ray tube to discover the electrons and determine its charge to mass ratio? So from this one, as a first better to start, fundamental subatomic particles. Fundamental subatomic particles are particles that are found in an atom. It should be classified into three. The first one is electrons, the second one is proton, and the third one is neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutrons are chargeless. Neutrons are what? Chargeless. That means no charge. So from this one, protons and neutrons found in the nucleus of an atom, but electrons are found in the atomic shell. It are found in the atomic shell. That means this one indicates an atom have two regions. One is atomic shell, the other one is atomic nucleus. So from this one, the first subatomic particle to be identified is what? Electrons. It should be identified by Johann Joseph Thomson. Johann Joseph what? Thomson, using cathode ray tube experiments. Using cathode ray tube experiments. This cathode ray tube experiment identifies the particles that have negatively charged and deflected towards the positive plates. This one indicates or explains that particles or every atoms have a negatively charged particles that deflect towards the positive. He called it what? Electrons. So the electrons are identified by Johann Joseph Thomson, and Johann Joseph Thomson also identified charge to mass ratio of an electrons. This charge to mass ratio of an electrons becomes the value 1.76 times 10 to the power of 8 gram per coulomb. This one, coulomb per gram. Coulomb per gram. This one is the work of Johann Joseph Thomson to identify the electrons. So the electrons are discovered or identified by Johann Joseph Thomson. This one is the first question. The second one, when students draw possible loss structure for hydrogens. Here it is hydrogen chemical formula. Hydrogen molecules. How many lone pair of electrons how many lone pair of electrons are available? As a first, it's good to see what does mean loose structure. Loose structure. This one explains or the simplest form of arrangement of electrons in the molecules. This arrangement of electrons in the molecule contain lone pair electrons, and the second one is bond pair electrons. Bond pair electrons. Look, lone pair electrons means the electrons that are not participate in the bond formation, but bond pair electrons are electrons that participate in the formation of the bonds. So, to draw the loose structures, we should be follow some steps. Some steps. The first one, determine what? Total number of electrons. Total number of electrons. We should be determine the total number of electrons and pair them. The second step, identify the central atom. Identify the central atom. The central atom, which is the most electropositive element. The most electropositive element. Most electropositive element. Electropositive element. This electropositive, most electropositive element means the atoms that have what? Larger size. That have larger sizes. This one is the central atom from the given molecules. The third one, arrange the electrons around the terminal atom and the central atom. So for example, if it becomes C2H2, we should write or draw the Lewis structure for this one. As a first, we should be determine total number of electrons. Carbon, 2 atoms of carbon times for 1 atom of carbon that have 4 valence electrons, which is equals to 8. There are 2 hydrogen atoms for 1 hydrogen atom that have 1 valence electron, which is 2. So total number of electrons, which is equals to 10. Then as a first, we should be put the atoms. Here it is. Carbon is the central atom because this one is larger size than that of hydrogen. And we should be put the hydrogen atoms just like this one. Then after this, we should be fulfill the terminal atoms as octet rule. So hydrogen contains 2 electrons. By sharing of electron, it becomes what? Helium-like electron configuration. So this one is 1 valence electron, and here it is 1. So the next one is 1, 2, 3, because 1 carbon atom have 4 valence electron. How can we know the valence electrons? It becomes 4, 5, or and so on. Carbon have atomic number 6. You should be write the electron configuration to know the valence electrons. 2, 4. That means the first one is K-shell, L shell. These electrons are called valence electrons. These electrons are called valence electron. So here it is 1, 2, 1, 2, 3, 4. This dot represents the valence electrons of the given atom. So here it is also 1, 2, 3, 4, 1. Hydrogen 1. Look this one. These electrons. Look these electrons. These electrons are shared electrons. Look, here it is. These electrons are shared electrons. These electrons are shared electrons that participate in the formation of the bond. So these are, then also this one is also shared electrons that participate in the formation of the bond. Here it is, or it makes just like this one. So this is known as what? 3 pair of electrons are shared between carbon-carbon atom to produce triple bond. So from this one, determine lone pair electrons and bond pair electron from this one. The lone pair electron, which is equals to 0, because all the electrons are participate in the bond formation. But the bonded electrons or shared electrons are, you should be count the number of bonds that are found in the given molecule. 1, 2, 3, 4, 5. So 5 times 2, which is equals to 10 electrons, because one bond contains what? 2 electrons. So based on this one, we can determine the number of lone pair electrons and bond pair electron for this atom. That means for hydrogens. So to determine this one, here it is hydrogen. The first step is determine total number of electron. የመጀመሪያ ስቴፓችሁ የምታደርጉት ምንድነው? ቶታል ነምበር ኦፍ ኤሌክትሮናችሁ ምን ያህል ነው የሚለው ነው ዲተርሚን እናደርግ። So there are 2 nitrogen atoms, 2 times 4 nitrogen atom, 5 valence electron አለው። So 2 times 5, which is equals to 10 electrons. ሁለተኛው ሃይድሮጅን አተም ነው። 4 ሃይድሮጅን አተም አለን። ታይም ለሃይድሮጅን 4 ሃይድሮጅን አተም አለን። ዜን ያን ሃይድሮጅን አተም ቫላንስ ኤሌክትሮን 1 ነው። So 4 times 1, which is equals to 4. Totally it becomes what? 40. Total it becomes 40. The second step, we should be pair them means what? This one is divided by 2. Pair አርጉት ማለት ቦንድ ሲፈጥሩን ፔር ሆኖ ነው። ሎን ፔርም ስናስቀምጣቸው ፔር አርገን ስለሆነ we should be divided by 2 to make pairs. It becomes what? 7 pair electrons. 7 pair electrons. So from this one, we should be draw the structures of this one. Draw the structure of what? This one. So the central atom is nitrogen. Here it is 1 nitrogen, and here it is 1 another nitrogen atoms. Then there are 4 hydrogen atoms. We should be put the 4 hydrogen atoms just like this one. Here it is the 4 hydrogen atoms. Then after this, you should be put the valence electron. Hydrogen have 1 valence electrons. Look, here it is. አራቱን የሃይድሮጅን አተሞች አስቀምጣችሁ 4 ኤሌክትሮን ታስቀምጣላችሁ። አንድ ኤሌክትሮን አለው። Then hydrogen produces what? A single bond. So just like this one, we should be make a bond. Here it is. This dot represents valence electrons. The remaining electron for nitrogen, because one nitrogen atom have 5 valence electrons. Here it is. Here it is. That means you can count the total number of electrons are become 14. Then 14 ካልመጣላችሁ total number of electrons ስህተት ነው ስናስቀምጠው then እንደገና ማየት አለብን ማለት ነው። Look this one. 1 2 3 4 5. That means one nitrogen atom have 5 valence electron. That means nitrogen atomic number 7 now. To know the valence electron, that means the electrons that are found in the outermost shell. No? The first shell holds 2, the second shell holds what? 5. That means using 2n square rule, to determine the number of electrons in each energy levels. Then after this, you can make a bond. You can make what? A bond just like this one. Look, this one is a bond. That means to make a bond, to identify which one is lone pair electron and which one is bond pair electrons. Bond pair na lone pair electron ለመለየት bondን produce እናደርጋለን. Then after that, bond formation ላይ participate ያላደረጉ electrons, we call it lone pair electrons ማለት ነው. Here it is 1 and here it is 2. So from this one, lone pair electron, which is equals to 2, 1, 2. Then bond pair electron, which is equals 1, 2, 3, 4, 5. Bond pair electron 5. That means to determine total number of electron, 2 times 2, which is equals to 4. Then 5 times 2, which is equals to 10. Total it becomes what? 14. This one is the correct structures of hydrogen. Then after this, look the casing. When students draw loose a structure for what? Hydrogen molecule, how many lone pair electrons are there? Or are available? The number of lone pair electrons are 2. Your answer becomes what? B. Question number 3. Compound that contain carboxy means what? Carbonyl and hydroxyl groups are said to be A ester, B ketone, C aldehyde, D organic acids. As the first, organic compounds are compounds that contains or that are derived from what? Living things and non-living things. Non-living things means like urea should be derived from what? Non-living substances to produce organic compounds. So from this one, these are hydrocarbons. Hydrocarbons are the compounds that contain carbon and hydrogen, and the other one is derivative hydrocarbons. Derivative hydrocarbons means what? Hydrocarbons. I mean that should be derived from hydrocarbons. Derived from hydrocarbons by replacing one or more hydrogen atom by another groups. For example, look this one. Here it is. We call it methane. We should be converted into derivative hydrocarbons. We should be replace one hydrogen atom with another groups like that of oxygen. So from this one, CH3, we remove one hydrogen atom. We should be replaced by OH group. This one is known as, or this compound is converted into alcohol. Alcohols are derivative hydrocarbons that should be derived from hydrocarbons. So from this one, the compound that contains carbonyl and hydroxy, so it's better to see what the functional group is. Functional group. What does mean functional group as the first? Functional group. Functional groups groups or molecules of compounds that determine the molecules, the physical and chemical properties of that molecule and that compound. For example, here it is OH. This one is a functional group for alcohol. This one is functional group for alcohol. COOH. This one is functional group for carboxylic acids. Carboxylic acid. Then here it is COH. COH, this one is aldehyde. Aldehyde. This one is a functional group for aldehyde. CO R prime. This one is ketones. This one is ketones. Then the other one COO R prime. Here it is ester. Here it is ester functional group, and the other one is ROR. This one is ether functional groups. So it's better to draw the structure to identify which one is carbonyl group and which one is hydroxy groups. As the first, we start from carboxylic acid. Here it is OH. This one is carboxylic acid. Then for aldehydes, here it is aldehyde. Then for ketones, here it is keton. Then for esters, here it is ester, and this one is ether. Here it is ether. So from this one, carbonyl group, this one is a carbonyl group. So for carboxylic acid, here it is carbonyl group. For aldehyde, there is also carbonyl group. For keton, there is also carbonyl group. For ester, here it is carbonyl group, but there is no carbonyl group for ether and alcohols. Then the second one, we should be identified by hydroxyl groups. Here it is a hydroxyl group, for the others are not. So the compounds that contain carbonyl group and hydroxyl group is what? Carboxylic acid or organic acids. Carboxylic acid or organic acids that contains what? Carbonyl group and hydroxy groups, but the other derivative hydrocarbons have no hydroxy groups. By this way, you can identify which one have carbonyl groups and hydroxide groups both contain. We call it carboxy group. So your answer becomes organic acid or carboxylic acids that contain both carbonyl group and hydroxy groups. The fourth one, the reaction between alcohol and acyl chloride produces. The reaction between alcohol and acyl chloride produces A ester, B carboxylic acid, C ether, C ester, D is aromatic salts. This question relates to what? Preparations of ester. Preparation of ester. Preparations of ester. Esters are prepared by the reaction between the first one, carboxylic acid and alcohol. Between this one, there is formation of ester. The second one is the reaction between acyl chloride with alcohol, also produces esters. So from this one, here it is one example of carboxylic acid. Here it is a carboxylic acid, ethanoic acid that reacts with alcohol, simplest alcohol. Here it is methanol. To produce this one as the first, there is what? Bond cleavages in alcohols and carboxylic acids. The bond cleavage in acids, hydrogen-oxygen bonds are cleaved. Carbon-oxygen bond cleavage, and in alcohols, oxygen-hydrogen cleavages to produce a smaller molecule, water. What about the remaining one? Here it is the remaining one, CH3, C, double bond O. Here it is O, CH3. Look, this one is ester functional group. Look, the structure or the functional groups of ester. COO R prime. In this case, this one indicates what? Alkyl group CH3. This one is R prime. R and R primes are equal or may not necessarily equal. So this one is ester. One preparation of what? Ester. The second one, acyl chloride. Acyl chloride, here it is the acyl chloride that reacts with alcohol, just like this one. Here it is one alcohol, methanol. So from this one, there is what? Cleavages. The cleavages are carbon-chlorine cleavage and hydrogen-oxygen cleavages in alcohols. Here it is the one cleavage. Look, to produce a smaller molecule, hydrogen chloride, and the remaining one is ester. CH3, CO, here it is COO, CH3. That means CH3, C double bond O, OCH3. This one is known as what? We call it esters. This one is known as ester. So the reaction between acyl chloride, here it is the acyl chloride means. This one is acyl chloride, and that of alcohol produce esters. This one is also the fourth equation. The fifth one, fats and oils are A acids, B alcohols, C esters, and D alkenes. So which one is the answer for this one? As the first, fats and oils are triester glycerins. This one is triester glycerins. So if this one is triester glycerins, the answer becomes they are what? Esters. But fats are solids or semi-solids. But oils are liquids at room temperature. Fats are solids and oils are liquids, but both fats and oils are triester glycerins. So fats and oils are what? Esters. This one is the fifth one. Question number 6. Which of the following is not both Bronsted-Lowry acids and Bronsted-Lowry base? As the first, it's better to define the concepts of acids and bases according to Arrhenius, according to Bronsted-Lowry, and according to Lewis. Starting from the first one, Arrhenius, acids and Arrhenius bases. Arrhenius acids are a substance that release hydrogen plus or hydronium ions in a reaction. Hydronium ions. That means when the substance are dissolved in water, that releases hydrogen plus or hydronium ions, that one is an acid. This means what? For example, here it is hydrochloric acid that dissolves into water to produce hydronium ions and chlorine minus. Hydronium ions and chlorine minus. Look this one. The concepts of Arrhenius means the substance that dissolves into water to release hydronium ions or hydrogen ions, we call it acids. The bases are substances that release hydroxide ion when it dissolves into water. ውሃ ውስጥ ዲዞልቭ በሚሆንበት ጊዜ OH ከለቀቁ ቤዝ ብለን እንጠራቸዋለን። H+ ወይም H3O+ ከሆነ ደግሞ አሲድ ብለን እንጠራቸው ነው። ፎር ኤግዛምፕል አሁን ሶዲየም ሃይድሮክሳይድን ውሰዱት። ይህንን ዲዞልቭ ኢንቱ ዋተር አድርጉት። ሶ ይሄ ዲዞልቭ ሲሆን ዋተር ውስጥ that releases hydroxide ions and what? Sodium plus ions. So this one is called as what? This substance is known as what? Bases. Based on what? Arrhenius concept. But he does not consider the reactions that occurs in gases or molecules and ions that have participate as acids or bases. The second one is Bronsted-Lowry acid-base concept. Bronsted-Lowry acids and bases. Bronsted-Lowry acids are substances that donate proton. Donate what? Protons. If the substance that donate protons is known as what? Acids. Whether the reaction takes place in liquids or in gases, it doesn't matter. But if it donates hydrogen plus, we call it bronze-telluric acids. Then bronze-telluric base means what? That accepts what? Protons. Accept protons. So if the substance, whether in gaseous state or in the aqueous solution, if it donates protons, we call it what? Bronze-telluric acids and bases. When when the substance donates proton and accept proton, there is formations of what? Conjugation. There is conjugate acids and conjugate bases. So what does mean conjugate acid and conjugate base? Conjugate acids are a substance that have one more hydrogen than the base, the base. But conjugate base means one less hydrogen than the acid. Look, conjugate acid ከሆነ one more hydrogen ይኖረዋል ከቤዙ የተሻለ ይሄኛው ደግሞ one less hydrogen ይኖረዋል. For example, look this one. Hydrogen chloride react with water H2O. Look, here it is the reaction H3O plus with that of Cl minus. Look this one. We should be identify which one is conjugate acid and which one is conjugate base. For this one, here it is the acid and this one is the base. Waters have what? Antiprotic species that act as acids and bases. That means both it donates protons and accepts protons. So this one is a conjugate acid and this one is a conjugate base. Look, the conjugate acid base pairs. This one is a base and here it is a conjugate acid. You can compare the number of acids of water molecule and hydronium ion molecules. The hydronium ion molecules have one more acid than that of the base. So here it is conjugate acid base pairs. For this one, here it is for this one. Look, this one is the acid and this one is a conjugate base. This one also one less hydrogen than that of what? The acid. Or you can define conjugate acids are one more positive charge than that of the base, and conjugate base means one less minus charge than that of what? The acid. በዚህ መሰረት ሁለቱን አይደንቲፋይ ማድረግ ትችላላችሁ፣ ኮንጁጌት አሲድ እና ኮንጁጌት ቤዝ። ሶ bronze-telluric አሲድ እና ቤዝ የሚሆነው ሰብስታንስ ቦዝ ፕሮቶን ዶነር ፕሮቶን አክሴፕተር መሆን አለበት። ቦዝ ፕሮቶን ዶነር ኤንድ ፕሮቶን አክሴፕተር ከሆነ ያ ሰብስታንስ ዊ ኮል ኢት bronze-telluric acid base concept ብለን እንጠራዋለን። So from this one, the last one is Lewis acid base concept. Lewis acid base concept. Acid base concept. Before that, bronze-telluric acids and bases are restricted only on what? Proton donors and proton acceptors. Proton donate and accept የሚያደርጉ ሰብስታንሶች ብቻ ናቸው አሲድ እና ቤዝ ብለን የምንጠራቸው። Otherwise, for example, ካርቦኔቶች ቢኖሩ ፖዚቲቭ ቻርጆች ወይም ሞለኪውሎች ቢኖሩ እነዚህ አሲድን ቤዝም ካፓቢሊቲ መኖራቸውን ዲተርሚን ያደርግላችሁ። So it have its own restrictions. That means limitations ብለን እንጠራለን። Lewis acid base concept ላይ ስንመጣ ግን it's a broad concept. So from this one, acids and bases. Acids and bases. Acids are electron pair acceptor. Electron pair acceptor. Electron pair acceptor ነው አሲድ ብለን የምንጠራቸው። So bases electron pair donor. Electron pair donor. Electron pair donors. Look, so from this one it indicates if the acids are electron pair acceptor, as the central atom there is what? Shortage of electrons ማለት ነው። Vacant space አለው it holds what? Electrons, but it have what? A vacant space. That's why it accepts electrons. Electron pair donor ብለን የምንጠራቸው ቤዞች ደግሞ ሴንትራል አተማቸው ላይ excess electron አለ. So they give the electron for the acidic substance to make what? A bond. Then at this time they produce coordination. Acid base coordination should be produced from the reaction. For example, look this one. Boron trifluoride react with ammonia NH3 to produce acid-base concept. So this one is shortage of electron. This one is act as acids, and this one is act as a base. How do you know it act as acids and it act as bases? You can draw the Lewis structure for this one. Lewis structure on ትሰሩታላችሁ። ለምሳሌ ቦሮን ሰራው። ቦሮን ሴንትራል አተም ነው። Here it is. The steps are similar what we do in the previous question. That means we should be determine total number of electrons, they identify the central atom, then pair them and so on. Then after that draw this one. Look, the central atom, how many bonds? 3 bonds. 1, 2, 3. 3 bonds multiplied by 2, which is equals to what? 6 electrons. That means the central atom have a capacity to hold 8 electrons. That's why it have what? Shortage of electrons. So it accepts pair of electrons to make what? Stable. So from this one, ammonia react with ammonia means, here it is, that have 5 valence electrons and it have a lone pair of electrons. So this atom gives the electrons, give what? The electron for boron to make these bonds. To make what? This bond. Look this one. Look this one. Look, after donating of the electron to the borons, that means this one is electron pair donor and this one is electron pair acceptor. That's why ammonia is Lewis base and boron trifluoride is Lewis acid is based on what? Donating of electrons and accepting of electrons. This one is more broad than that of what? Bronze telluric acids and arsenous acid-base concepts. Generally, arsenous acid-base concepts are a proper subsets of bronze telluric acid-base concepts. Bronze telluric acid-base concepts are proper subsets of Lewis acid-base concepts. That means የአርሴነስ አሲዶችና ቤዞች የብሮንዝ telluric አሲድና ቤዝ ናቸው። የብሮንዝ telluric አሲድና ቤዝ የሆኑት ደግሞ Lewis acid base ላይ እናካታቸዋለን። አሁን currently the modern definitions of acids and bases are Lewis acid base concepts now. So based on this one, which one is act as both bronze telluric acid and bronze telluric base ይላል። ስለዚህ ሁለቱንም ነው ፕሮቶን ዶነርም ፕሮቶን አክሴፕት የሚያደርገው ሰብስታንስ ምንድነው ብለን እንጠራዋለን? ያ ሰብስታንስ bronze telluric ቤዝም አሲድም ነው ብለን እንጠራዋለን ማለት ነው። አንቲፕሮቲክ ስፒሺስ ብለን እንጠራዋለን። that means both act as bronze telluric acid and base ነው። so from this one ይሄኛውን react with water ብታደርጉት ዶኔት ያደርግላቸዋል። then ይሄም ዶኔት ያደርጋል፣ ይሄም ዶኔት but hydroxide ions acceptም ዶኔትም ነው የሚያደርጉት። ይሄኛው ሶስቱም acceptም ዶኔትም ያደርጋሉ። both bronze telluric acid base concept acids እና bases ናቸው። OH ላይ ስትመጡ ግን only accept ብቻ ነው የሚያደርገው። so both bronze telluric acid እና base መሆናቸውን your answer becomes B. OH minus ions ነው። ስድስተኛው በዚህ እንለፈው። ሰባተኛው ላይ ስንመጣ A dash change in enthalpy corresponds to N dash process ነው። Look from this one, in chemical reaction, in what? Chemical reaction. Almost all chemical reactions are occur in what? Energy changes now. That energy change, whether endothermic process or exothermic process ነው የሚሆነው። exothermic process, endothermic process ወይም exothermic process ነው። then as the first better to define change in enthalpy or heat of reaction ብለን የምንጠራው amount of heat absorbed or liberated from the chemical reaction change in enthalpy ብለን እንጠራዋለን። so which is equals to heat of product minus heat of what? Reactant. If heat of product is greater than that of heat of reactant, the process is endothermic process because what? Change in enthalpy becomes what? Positive. Change in enthalpy becomes positive means to proceed the reaction we absorb energy. Heat flows are from the surrounding into the system ይሆናል ማለት ነው። ሁለተኛው change heat of reaction, heat of what? product is less than that of heat of reaction ሲሆን exothermic process ብለን እንጠራዋለን exothermic process ብለን እንጠራዋለን why we call it exothermic process change in enthalpy ምንድነው ኔጌቲቭ ይመጣል energy by itself negative ይሆናል ማለት ሳይሆን the energy is released from the reaction ነው for example the best example for exothermic process ብለን የምንጠራው a respiration reaction ነው a respiration reaction a respiration reaction means this one glucose burned with oxygen to produce carbon dioxide water and what energy that means the food we eat glucose now then we inhale oxygen the food the food is burned with oxygen to remove carbon dioxide water and energy is removed from the reaction ይሄ ከሆነ ምን ብለን እንጠራዋለን exothermic process ነው because energy ከሪአክሽኑ ላይ ምን ሆኗል released ሆኗል ማለት ነው at this time change in enthalpy ምን ይመጣል ኔጌቲቭ ይመጣል so from this one negative endothermic ይላል false ነው ኔጌቲቭ ከሆነ ምንድነው ብለናል exothermic process ነው ብለናል ቢለስ መጡ positive exothermic ይላል ይሄ ውሸት ነው positive ከሆነ endothermic process ነው የሚሆነው positive endothermic this one is correct positive endothermic means absorption of energy or the flow of heat is from the surrounding to the system ነው exothermic ከሆነ ግን ከሲስተሙ ላይ ወደ surrounding heat flow ይኖራቸዋል ማለት ነው so the correct one is what positive ከሆነ when it is positive here it is what endothermic process negative ካረጋችሁት እዚህ ጋር here it is negative ከሆነ exothermic process ነው የሚመጣ the answer becomes what C ማለት the answer becomes C question number 8 chlorine has an oxidation number of +5 so as the first what does mean oxidation number that means the numbers or the electrons that participate in the formations or in the compound formation two types of electron are there one is valence electron ብለን እንጠራው ነው ሁለተኛው valence number or oxidation state number ብለን እንጠራው ነው valence number or oxidation state number ነው valence electron ብለን እንጠራው the electrons that are found in the outermost shell ሲሆን valence number ብለን እንጠራው ወይም oxidation state number ብለን እንጠራው the electrons that participate in the reaction or the capacity power of an atom to react with the other one ብለን እንጠራው ነው so easily to determine the oxidation state number of chlorine for each compound you should be make x for the unknown one chlorine ሁሉም ላይ x አርጋችሁ ወሰዱት then hydrogen sodium oxidation state number 1 ነው plus and then plus x minus oxygen oxidation state number minus 2 ነው but it have plus 1 oxidation state number አለው ሶስት የተለያየ oxidation state number አለው የኦክሲጅን depending on the compound ነው አንድ ሁለት አላሳያችሁ የኦክሲዴሽን ስቴት ነምበር ኦፍ ኦክሲጅን እንውሰድና for example in this case oxygen difluoride ላይ ስንመጣ electronegativity of fluorine is higher than that of oxygen ነው in this case oxidation state number of oxygen plus 2 ይመጣል but the other one ለምሳሌ ደግሞ ሱፐር ኦክሳይዶች ላይ ብንመጣ ሶዲየም peroxide ላይ ብንመጣ here it is sodium peroxide at this time oxidation state number of oxygen ስንመጣ ስንት ይመጣል -1 ይመጣል then peroxide just like this one sodium peroxide ብንመጣ እዚህ ጋር ደግሞ ስትመጡ plus -1/2 ይመጣል -1/2 ይመጣል ሶስት አይነት oxidation state number of oxygen አለን ከዛ ውጭ ግን in normal oxide ላይ ከሆነ oxidation state number of oxygen -2 ነው ማለት ነው -2 እንዴት መጣ ካል ኦክሲጅን ይሄ ነው 6 ነው 2 6 8 ለመሙላት የሚያስፈልገው ኤሌክትሮን 2 ነው ይቺ ምን ተብላ ትጠራለች oxidation state number of oxygen ብለን እንጠራታለን ማለት ነው so ይሄን ስትወስዱት x which is equals to +1 which is equals to 0 ብላችሁ ስለምትሉ እዚህ ጋር +1 ነው oxidation state number of chlorine እዚህ ጋር ስትመጡ 1 plus x minus 4 ይመጣል because 2 atoms of oxygen አለ 2 times -2 -4 ይመጣል እዚህ ጋር ስትመጡ ደግሞ plus 3 ይመጣላችኋል ሲ ላይ ስንመጣ 1 plus x minus 3 times -2 6 ይመጣል which is equals to 0 ነው x which is equals to plus 5 ይሆናል እዚህኛው ጋር ስትመጡ then እዚህ ጋር ስትመጡ 1 plus of x minus 8 x which is equals to plus 7 ይመጣል። this is the oxidation state number of chlorine in each compound ማለት ነው። ሶ በዚህ መሰረት ዲተርሚን ስታደርጉ የክሎሪን ኦክሲዴሽን ስቴት ነምበር ፕላስ 5 የሚኖረው እዚህ ጋር ነው። so your answer becomes C ማለት ነው። this is question number 8